So hello everyone, our senior project is called ItsMe. ItsMe is a smart lock that's designed for high portability and seamless installation for users. So the purpose of this project was to develop a device that remotely controls a deadbolt lock with a smartphone, but caters more towards tenants, apartment holders, and users that travel frequently than industry smart locks do. The main features of our design are that it's meant to be installed through plain attachment onto a door's lock rather than having to take apart the door and replace its lock like most industry smart locks. This makes it easy for the user to uninstall and move the lock somewhere else without damaging the door. It also has a completely open source and modular design, allowing users to modify it to suit their needs, then 3D print it and assemble it at a low cost. So this diagram summarizes the planned architecture for our system. On the left, we have our smart lock. The smart lock consists of a 3D printed rotation and gripping mechanism that's wired to a Raspberry Pi and then surrounded by an enclosure. The enclosure is then attached to a door by a heavy-duty adhesive strip. And on the right, we have an Android app that communicates with the device's Raspberry Pi through Bluetooth.
So here you can see a graphic of the prototype we had. And as you can see, it involved a mechanical portion, which was done in SolidWorks. And although it's a simple mechanical system, we were really appreciative of being able to branch out and refine new skills in CAD. The overall device weighs 250 grams, and the manufacturing cost was approximately $60 and will be expanded upon on the next slide. This design includes 3D printed parts and gears for full customization, and I wanted to emphasize that the prototype was designed for modularity in mind and to really minimize the work for extra assembly, as there's no really extra fasteners required. For example, the grip can be modified, and the servo mount is able to slide to accommodate changes in like gear sizes in the development process. So I wanted to note that in our current design, we have used the Raspberry Pi rather than the Raspberry Pi Zero because we were unable to transition into the smaller form factor due to inaccessibility to tools at school. And we can observe that the $60 cost is heavily weighted towards the electronics of the device. And most devices in the current market run at around $200, so ours has the advantage on that end.
So for the previous slides, we were elaborating the previous progress of what we have done so far during the last semester. And from this slide, we'll try to explain more like how we progressed on during this semester. The left picture is showing how our prototype looks like with the Raspberry Pi 3. And the picture on the right is showing our application status picture of like how our app is actually working. The actual product was developed slightly different from what we have intended last semester because of some technical issues, but we were able to implement the core features for working. So far, our first device prototype and Android app beta version is completed, and some core features included in this project is that our 3D printable mechanism is on our open source design on GitHub. So anyone who wants to print out or anyone who wants to use this lock can download the 3D design from the GitHub and just use 3D printer to print anywhere. Also, gripping mechanism supports multiple sizes deadbolt locks. We were unable to show all the demos of how this lock is working on like different sizes of deadbolt locks, but we tested on like 2 or more locks that we have on our home to showing that like it grips it perfectly. And Bluetooth compatibility between app and devices working fine. We tested out wirelessly through our phones, different phone, like 2 or more, and then it seems like it works fine. And also it saves the lock status to avoid the malfunction, because if you are like forgetting about lock status, then what happens is it can run like in the same direction again and again. But now we can save the current lock status, and then machine can load the lock status and then perform the next step. Also, it remotely unlock or lock the lock, so that like without any wire, without any like protocol, we can use it remotely. Also, it has some low manufacturing costs, like as stated before, and then also in lightweight, we could use some adhesive tapes, and then we could use just simple tapes to put the blocks onto the door. Due to the technical issues, there were features that haven't been completed yet. We tried to use some like enclosure on the top of the machine, but for now, like we didn't have like facilities to do that. And also, we tried to share keys across the users, but that also requires some databases and some like web app. So we don't have that feature so not yet.
Now we would like to show the demonstration of our smart lock. The first video will show the test that was made to check the exact rotation of the lock in an exact angle to enable controlling the actual deadbolt lock attached on the door. And the second video shows the actual locking and unlocking process of the smart lock by using the Android mobile application that we have made. Although our group tried to resolve all the issues with the smart lock, we still had some remaining limitations. Firstly, due to the graph shape we have designed, our smart lock only supports the deadbolt locks. Also, since the material we used to build the device is not hard enough, it is necessary for us to use harder material with different connecting shape to improve the stability of the device. Another issue was using the Bluetooth connection. Although the suggested range of the built-in Bluetooth of the Raspberry Pi 3 is stated as like 5 to 7 meters, since the effective range of the Bluetooth is strongly affected by the obstacles and the receiver type the users actually use, the exact effective range for the various devices that will be used along the smart lock are not fully figured out. Among the additional features we have aimed, the auto lock feature when the lock is out of control is not yet implemented. And our future works that can improve the project will be creating registration system with printed ID on this smart lock and adding some more security measures in the system. Thank you.